Okay, guys, similarity is it's not the same as congruency, but we're going to use the same method. Do you guys remember that we've done congruency before? Proving that two triangles are identical. All right, and then we had to look out for three things equal to three things. All right, we're going to do a similar thing here, but with similarity, I'm just going to write down two triangles are similar. And all types of shapes can be similar. You can talk about squares that are similar, rectangles that are similar, even circles that are similar, but we only work with triangles. Okay, so two triangles are similar if, now there are only two ways in which we can prove it. Do we remember that for congruency there were four? All right, side, 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 angle, angle, side, and right angle, hypotenuse, side. Okay, similarity is much easier. For similarity, it's only angles or only sides. All right, so the first way of proving it is that the corresponding angles are equal. Now I'm going to explain to you in a little bit what I mean by corresponding here. I'm not talking about the F shape. All right, when I'm talking about corresponding angles in different triangles, we're not talking about the F shape here. So I'll show you what I mean by this. The corresponding angles are equal. All right, that's one example. We're going to just quickly draw two triangles here, just so that you can see what I mean. Now guys, if you're looking at my two triangles, are they identical? Are they the same size? Okay, no. All right, that's the thing with similarity, they're actually not identical. Congruency, if triangles are congruent, then they are identical. They have the exact same shape and the same size. With similarity, they can be different sizes, but they have to have the same shape. Okay, so we can add that next to our heading. So similarity, we need to have the same shape, but different size. Sizes, I suppose, you can say. All right, so you can have a small triangle and a big triangle, but if the two triangles have the exact same shape, all right, I try to make my triangles look like they have the same shape. So they have kind of a pointy side going out to the right, all right, then they can be similar. Okay, they don't have to have the exact same size. With congruency, they have to have the same shape and the same size. Okay, they have to be identical. Now, guys, if we're looking at these two triangles that we've drawn now, is it starting to become clear what I mean when I say corresponding angles are equal? So you have a 65-degree angle in the one triangle, and you have a 65-degree in the other triangle. All right. Then at the top or above the 65-degree angle in the small triangle, you have an 85-degree angle. The same thing happens in the big triangle. Above the 65-degree angle, you have an 85-degree angle. All right. Then in the bottom right corner, you have a 30-degree angle next to the 65. In the other triangle, it's the same thing. Next to the 65-degree angle, we have a 30-degree angle. Okay, that's what they mean when they say the corresponding angles are equal. So it's almost like you have the same three angles in both triangles, right? Does that make sense? So you have a 65 and an 85 and a 30-degree angle in both of them. Okay, that's what they mean when they say the corresponding angles are equal. So that is one way in which we're going to prove similarity. So guys, what we'll do, we're going to do the same 5-line proof that we did for congruency. We're just going to say A equals D, B equals E, C equals F. Therefore, this triangle is similar to this triangle. Okay, easy. 3 angles, done. The second way of proving, and this one is a bit more difficult, we will do examples, is that their corresponding sides are in proportion. Now, in proportion, that basically means, you'll see now when we work it out, this is like the same ratio or the same fraction. So again, I'm going to do 2 triangles and we'll just write down the values. Sorry, I just want to calculate my sides for the other one quickly. Okay, now guys, if we're looking at these 2 triangles, again, I tried to draw them so that they have the same shape if it's a bit off, it's not the end of the world. Do we notice that we only have 1 angle in each of these triangles, right? We only know that that's a 90-degree angle, that's a 90-degree angle. We don't have any of the other 4 of the 6 angles in total. All right. So we can't say that because we have 3 angles that are equal, 3 pairs of angles that are equal, they are similar. All right. They did give us all of the sides though. Okay, so now we're going to see if the corresponding sides are in proportion. Now guys, if we're looking at the smaller triangle, what is the shortest side in the smaller triangle? What length is the shortest one? AB, right? And that is a length of 2. Which length or which side has the shortest length in the bigger triangle? DE, which is 3. Okay, so let's write that as a fraction. Because here where they say in proportion, that means that you can get to the same fraction. Okay, so we're actually going to work with fractions for this. So we are going to say shorter or shortest in triangle ABC over shortest in triangle DEF and this is not how we're going to write it down when we're actually proving these. Okay, I'll still show you that. I just want to explain to you what the in the same proportion thing means. Okay, how you will be able to figure that out. So now we said that the shortest side in triangle ABC is AB. over the shortest side in triangle DEF is DE. And now we fill in the values. That is 2 over 3. And is that the fraction in its simplest form? 2 over 3. Right? I can't divide any numbers into 2 and 3, so that's simplest form. Okay, guys, if you're ever confused or not sure if a fraction is in its simplest form, just type it into the calculator, and the calculator will give you the simplest form always. Okay. So now we've done the shortest sides, and we see that the ratio, right, the proportion, the fraction of the shortest side over the shortest side is 2 over 3. Let's see what we get when we pair the other sides up. What is the middle side in ABC? BC, right, with a length of 3. The middle side in DEF is EF with a length of 4.5. So let's do the same thing, all right? So middle, not really middle, but it's like the middle value. It's not the shortest, it's not the longest. You know what I mean? So the middle length basically in triangle ABC over the middle one in triangle DEF. All right, so I said that that was BC in the small triangle and EF in the bigger triangle. So that is 3 over 4.5. Now, guys, we don't normally have decimals in our fractions, right? So let's type this into the calculator and see what it gives us. 3, and then we use our fraction button, and then we type 4.5. Oh, the simplest form of that fraction is also 2 over 3. Do we see that we're getting the same ratio, the same fraction, the same proportion, right? And that's what happens when we have similar triangles. If we take a length over a length, it will always simplify to the same fraction. Let's quickly do the longest sides. All right, so the longest in triangle ABC, and you would have to check all 3 of them. Okay, when we actually do our proper proofs, we're going to also have to do 3 of them every time. So the longest in triangle ABC over the longest in triangle DEF. What is the longest side in triangle ABC? AC, right? And the longest side in DEF is DF. So we have 5 over 7.5. And again, if you type that into the calculator, we get 2 over 3. Again, we get the same fraction, the same ratio. All right, so because these fractions can all simplify, are all actually equal to 2 over 3, we say that these sides are in proportion. All right, that is the terminology that we use. Say that the sides are in proportion. So that means that these 2 triangles are similar. And actually what happened, guys, is that this smaller triangle was enlarged. All 3 of the sides were enlarged in the same ratio to give us the bigger triangle. Or if you want to go from the bigger triangle to the smaller one, you can say that each 3 or all 3 of the sides of the bigger triangle were reduced. I forgot that word now for a second. Were reduced in the same ratio or by the same number to give you the size of the smaller triangle. Now, guys, if I say 2 and I multiply it by 1.5, I'm going to get 3, right? Let's check that quickly. 2 times 1.5 is 3. Okay, so to go from the shortest side to the new shortest side, you would have to multiply by 1.5. That's not a part of the question, okay? I'm just showing you. We're just discussing this. So that means that because these two triangles are similar, if I do the same thing with the other two sides, I'm supposed to get the two sides in the new triangle, all right? So if I say 3 multiplied by 1.5, that's supposed to give me 4.5. Let's see if that happens. 3 multiplied by 1.5, that does give me 4.5. Yes. They're not going to ask it like this, so we're just discussing it. All right, so 3 multiplied by 1.5 will give me that. And now it should work out the same way for the other one, right? If I say 5 multiplied by 1.5, it's supposed to give me 7.5. Let's see if that happens. 7.5. All right. So that's actually what we're proving, guys. We're actually showing when we take a side in the one triangle over a side in the other triangle, and then we do the same for all 3 pairs of sides, we're actually showing that each new side is in fact a multiple of the previous side. Okay, in this case, we multiplied it by 1.5. That's not very important now, how we get the 1.5. I'm going to show you a nice method of finding that out. Okay, but does it make sense that that's what we're doing? Right, so if I had a 2 and a 3 and a 5, right, and I then have a 4 and a 6 and a 10, if I'm multiplying each side by 2, that will also give me a similar triangle. If I'm multiplying each side by 3, that will give me another similar triangle. All right, so if you're multiplying each side by the same number to give you new sides of a new triangle, the two triangles will be similar. All right, we're going to do lots of work still around that. I just wanted us to understand where these two methods are coming from. Okay, now I'm going to show you how to actually prove it. So this is not how we're going to write it down. On a new page, please. I suppose it depends on how much space you've used up. But I'm going to start on a new page, proving similarity. And that's going to be a bubble heading. Okay, so now we're actually going to do the proofs. Okay, we're going to do some examples. So I'm going to write number 1 and we're going to draw the triangles. Okay, now guys, I want you to notice that they've actually only given us 2 angles in both of our triangles, right? But are the 2 angles that they've given us, are those the same? At least. Okay, we have 90 and 90, and we have 60 and 60. Now remember, if we're proving similarity, we have to show that all 3 angles are equal to all 3 angles, all right? Or that you have a 90 equal to 90, 60 equal to 60, and then this angle must also be equal to that angle. Now, can I calculate these 2 angles? Right? What do we know about the angles in a triangle? They have to add up to 180, all right? So let's quickly do that before we even start proving that our triangles are similar. Angle T is going to be 180 minus 90 minus 60. And what is the reason for that, guys, when you use that? Can anyone remember? Yes? Yes, good. Angle sum in triangle. Right, so because we know that the 3 angles must add up to 180, if we're just missing one, we minus the ones that we have from 180, and then that will give us the one that we're missing. Okay, so this will give us 30 degrees. So T is 30. Now guys, am I not going to get the same answer for Z? What do you think? What am I going to do to find Z? I'm going to say 180 minus 90 minus 60. I'm going to do the same calculation. So I will definitely get 30 as well, right? Does that make sense? Do I even have to calculate that? If I know that these 2 are already equal, then the third ones will definitely have to be equal, right? So this one will definitely also be equal to 30. Now guys, that will always happen. If you have 2 triangles and you have that 2 pairs of angles are already equal, then the third pair of angles will automatically be equal as well. Because this is what's going to happen. You're going to have 180. You're going to minus the same 2 angles from 180, which will have to give you the same answer. Right, so later on you'll see that sometimes we don't even have to calculate it. We can just say straight away, they will be equal. And our reason is going to be angle sum in triangle. Okay, when we do another example, I'll repeat that. But I'm just going to say again quickly, we didn't actually have to even calculate that these angles are equal to 30 degrees. Because we know that to get the third angle, we would have to say 180 minus the 2 that we have. And we have the same 2 angles in these triangles. So if I minus the same 2 angles from 180, I will get the same 2 answers, right? So you don't actually have to even do this calculation. You can just say T will be equal to Z, reason, angle, sum in triangle. Okay, but we'll do that again later. All right, let's do our actual proof. In triangle TUV and triangle XYZ. Remember, that's how you always start your proof. We did the same thing with congruency. Now, just like with congruency, we're going to list the things that are equal, all right? So, angle U is equal to angle X. How did we know that? Given. Do we remember that we had to write given about 1,000,000 times when we did congruency? Same thing here, unfortunately. Number 2, V is equal to Y. Also given, right? They filled that in on the picture. They are giving us that information. And now T is equal to Z. Now that was not given, right? They didn't fill those values in, but because of angle sum in triangle, we know that those 2 angles will definitely be equal. Guys, I just want to add here as a note, this will always be your third reason. In some cases, you can write something else as your third reason, right? But actually, to save yourself some time, if you already have that two pairs of angles are equal, you don't even need to look at the other two, all right? The other two angles are left. You don't even need to look at the third pair. You can just say automatically, this one will be equal to that one because of angle, sum, and triangle. Okay, so actually we only need to prove that two angles are equal, then the third ones will be. Okay, therefore, triangle TUV. Now, guys, the symbol for similarity looks like a parallel symbol, but it has three lines. Remember, congruency looks like an equal symbol with three lines. Okay, similarity is like a parallel symbol, but three lines. So three vertical lines next to each other. Triangle, and now we have that same order thing that we did with congruency. All right, we have to list them, write the letters in the correct order. So here I wrote T first. Which angle is equal to angle T? Z. So if I wrote T first, I must write Z first for the second triangle. Then I wrote U. Now which angle is equal to U? X. So I must write X in the same spot as U. And then obviously the one that's left is Y, but we said V, and V is equal to Y. So we have to put Y in the third spot. Now the reason here, guys, is equiangular, which is a bit of a pain. All right, it's quite a long reason, but that is what it says in the CAPS document. Equiangular, that's just saying all equal angles, right? So that is your reason for similarity here. Okay, so with congruency, we can use those abbreviations with three letters. With similarity, unfortunately, we need to write words. So equiangular, if it's like this, where we've proven that the angles are equal. If we do the sides, we're going to say sides in prompt. Okay, so for similarity, it's always a word as your reason. Any questions on this one, guys? Okay, let's quickly do one with sides. Oh, now these sides are exactly the same as the ones that I just used in the previous one. Let me just see if I can find another one quickly. Okay, it's fine. I'll just make some up. Okay, guys, we have two triangles here. Did they give us any information about the angles? They haven't given us any angles. Okay, so they want us to, we have to work with sides here. Okay, they've given us all the sides and all the sides, so we can do that. So guys, we're basically going to do what we did on the previous page. So it's going to be more structured, and we don't have to say longest side over longest side. We can just write the names of the sides and then the reason or the values. Okay, so it's a bit shorter than what we did previously. My blue pen. All right, so we're going to start by saying in triangle MNO and triangle PQR. Remember, in the heading, we don't care about the order, right? We can use any order in the heading. It's in our final line. Once we've said what's going on, that we have to do the order correctly. Okay, now I usually start with the shortest side over the shortest side, then I do the middle one over the middle one, and then the longest side over the longest side. Okay, in this case, guys, if we just look at the values that they've given us, can we already see that the sides are in proportion? If we look at that one, 4 and 2, and we have 7 and 3.5, and we have 6 and 3. Right, what does it look like? It looks like each of these sides have been halved to get these sides, right? So we can already see that they actually are similar, but we need to write it down properly. Okay, so what is the shortest side in the big triangle? MN. So we're going to say MN over the shortest side in the small triangle, which is RP or PR. It doesn't really matter. And that is 4 over 2. So then you fill in their values, and then if you can, you have to simplify that. Okay, so in this case, we're actually getting 2. We're getting a whole number. Now, the reason for that, guys, is because now we're starting with the big triangle first. Okay, in the previous question, we started with the small triangle over the big triangle. That's why we got a fraction. Okay, but it's fine. You can go either way. It doesn't matter. Okay, number 2. What is the middle side in the small, oh, sorry, in the big triangle, in this first triangle? The middle side is MO, the one with the length of 6. All right, so MO over the middle side in the small triangle is RQ, which is the one with the length of 3. So it's 6 over 3, which again is 2. Okay, now we just have the last pair. So the longest side over the longest side. So the longest side in the big triangle is NO. And that will then be over the longest side in the small triangle, which is PQ. So that's how you match them up. Okay, you look at which ones are the shortest ones, in the middle ones, and the longest ones. So it's 7 over 3.5, which again will give you 2. Now, since we got the same answer, whether it's a whole number or a fraction, it doesn't matter. When we simplify these, we get the same answer. That means that the 3 pairs of sides are in proportion, so they are similar. All right, so therefore, triangle MNO. Now guys, it's a bit more difficult to get the order correct when we have sides. Okay, when we've done the angles, it's easy because we've listed this angle is equal to that angle. This angle is equal to that angle. All right, we don't have that now. So what I want you to do is, you can see here that when I labeled, when I named my first triangle, that I started with M. Now M is the angle that is opposite the longest side. Okay, do we see that? Angle M is opposite the longest side. Which angle in my second triangle is opposite the longest side? Which side is the longest side? 3.5. Which angle is opposite that one? R. Okay, so that's how you're going to do it when you have sides. Okay, so let's do our similar symbol, triangle. Like I said, M is opposite the longest side. In the other triangle, R is opposite the longest side. So I'm going to write R first because I wrote M first. then N is opposite the middle side, right? In the second triangle, which side is the middle side? This one, right? P is opposite the middle side. So if I said N second, that's opposite the middle side, I have to say P second because that one is opposite the middle side. Then the last one can only be Q, but let's just check whether that is correct. O in the big triangle is opposite the shortest side, right? In the small triangle, the angle that's opposite the shortest side is Q. Okay, so you're going to do it like that. And then you say sides in prop. That is the reason when you've used sides. Okay, any questions at this point? These are the only two examples that I'm going to do now. I'm going to give you two to do for homework that are just like these two examples. Okay, then on Friday, when I see you again, we're going to mark the homework and we're going to do more examples that are slightly different. Okay, and then we'll practice them as we carry on. So in the notes, I'm just going to write here, homework. It's in the notes. I'll put it on the board now so that you can take a picture of it. It's exercise 1. Which is on page 4 of the note. And I want you to do numbers 2.1 and 2.3. Okay, now I just quickly want to show you how those questions look. So it's exercise 1, numbers 2.1 and 2.3. So this is the whole exercise. Okay, it starts with number 1 and then there's number 2. All right. So 2.1 is the first one that you're doing, this one. They're saying prove that triangle EFG is similar to triangle RST. Guys, just like with congruency, if they've used the symbol in the question, they've already given you the correct order. Okay, so you don't still have to worry at the bottom that you have to figure out the order of your vertices or your letters. This is the correct order if they've used the symbol. Okay, let's just write that in again because it's been a while. So I'm writing it here. Obviously, you don't have this page printed. So symbol is given there. Therefore, that is the correct order. In the examples that we did just now, we wrote the words is similar to. Okay, so we didn't use the symbol in our question. So there you can't assume that that's the correct order. Okay, but if they give you the symbol in the question, then they've actually given you the correct order. Guys, here we have two triangles, right? They've given us 90 and 90. Do we have other angles that are equal? We have a 73. Do we have a 73 here? No. We have a 17. Do we have a 17 here? No. So in this case, you're going to have to calculate one of the other angles. Okay. Let's quickly do that calculation here. If you have to find angle E, let's check on the calculator. Remember the three angles must add up to 180. So E is going to be 180 minus that one, which is 90, minus this one, which is 73. There we get that it is in fact 17 degrees. All right, so you're going to have to say, obviously F is equal to S, that's given. E is equal to R, was that given? Okay, did they tell us that this one is 17? No, we worked it out. All right, so you're going to say E equals R, and what did we use to work that out? Angle sum in triangle. Now guys, if I have 90 and 17, isn't this one also going to have to be 73? Right? So then you're going to say G is equal to T, also because angle sum in triangle. Okay, so that's going to be the first one. 2.3. Now this looks a bit different from what we've just done, but what they've actually done here is they just drew the smaller triangle inside the bigger one. Okay, I don't want you to be thrown off by that. They're saying prove that ABC, the big triangle, is similar to EFD, the small triangle. Again, they've used the symbol, so this is the correct order of the letters. Okay, but can you see that they've only given you sides? So you're going to have to work with sides and prop. So all you're going to do is you're going to say in the big triangle, which one is the shortest side out of 15, 39, and 36? 15 is the shortest one, right? You're going to write that over the shortest one in this triangle, which is 5. You're going to say 15 over 5, simplify that. Then you're going to do the same with the other ones as well. Okay, so it's just been drawn differently, but it is again a big triangle and a small triangle. Okay. Right, guys, I am going to leave it up like that. We can, yeah, I'm gonna have to zoom out so that it can, actually, maybe I can do this. Zoom in. Okay, is that fine like that? Right, you're going to start working on that now. You have 15 minutes. You can definitely finish at least the first one, maybe both of them. All right, they're just like the ones that we just did. Okay, that is your homework for Friday, guys. You don't have maths tomorrow, so you don't have to do any work at home.